Then let's go to this. And see if it works. Ha! It popped up there. We're in business. I think. Let's see what happens if we... Where's the deal? There it is. What? Oh, there. There's what I'm looking for. A little pop-up job. Page 365, topic 6.4. Did I tell you on Wednesday that we skipped 6.5? Because we'll do 6.6 on Monday, the practice test on Wednesday, and the exam on Friday. If you are so sad that we're skipping 6.5, I know what I can do. I can go to the video place and label the one from last year so you can learn it on your own. Because I'm sure some of you are going to feel like you were shortchanged because of that snow day, and you'll want to go over that material. Why are so many of you smiling when I say this? You think I don't need to go identify that place? There might be one person out there who would like to have me identify that place. In problems 1 through 14 on page 365, factor each expression. So here's problem number 2. Factoring quadratic equations. That's what they're called. Now, here's what this means. See this thing right here? That's the answer to a multiplication problem. I had two things here, two binomials that I multiplied to get this answer. Factoring means I take the answer and find the two things I multiplied to get it. Well, guess how I get the first term? I take the first times the first. X times X. You follow me? So I put an X here and an X here. Then how do I get the last term? You say, why so many? Well, I could have 2 times 5, right? Or I could have 1 times 10. Or I could have negative 2 times negative 5. Or I could have negative 1 times negative 10. Don't you agree that all of those would give me positive 10 for my last term here? So out of these 4 possibilities, which one is going to give me 7x in the middle? Did any of you learn FOIL any place in life? The first is the first times the first. The last is the last times the last. And OI, and you just need to write this down. OI is you multiply the outside. I'll turn this up a little bit. This is X, and this is X. And then you multiply the inside, and you add them together. So what's negative 10 times X? What's negative 1 times X? What happens when you add those together? Negative 11x. Does that look like positive 7x? What? No. So that one's no good. You follow what's going on? I put all the possibilities out there, and then I just keep trying them. So put x in here. I know I'm going to get x and x, so x and x. So what's negative 5? Now, let me just, now how do I do this? Okay, I'll change to black here. What's negative 2 times negative x? Negative 2x. That's the inside. Then the outside, what's x times negative 5? Negative 5x. What's that add up to? Negative 7x. Is that what I want? It's 7, but it's negative instead of positive. So guess where I go next? I say, okay, this one's no good, but 2 and 5 gave me the right numbers. So I'm going to go up here and I said, I'll bet this is the one I want, x plus 2 and x plus 5. And let's do the outside. And what do you get when you multiply the outside? 5x. What when you multiply the inside? 2x. And what does that add up to? 7x, positive 7x. That's what I have there. So it's x plus 2 and x plus 5. And that is called factoring. Does that make sense? If I multiply these two things right here together, it produces this answer. Now, maybe some of you are saying, I don't see that. Okay, let's come over here and let's just do this for fun. Let's go x, whoops, let's change colors here. Let's go x plus 2 times x plus 5. Let's take this whole thing here and multiply it times each one of these. That distributive property. What's x plus 2 times x? X squared plus 2x. Agreed? What's x plus 2 times 5? Plus 5x plus 10. Put the 2x and the 5x together and you get x squared plus 7x plus 10. Is that cool? That's the same thing we have written over there, isn't it? You understand what we're doing when we're doing factoring? We're taking the answer and finding the two things we multiplied to get that answer. And the technique we use for doing that looks pretty messy right now, doesn't it? But let's go down and do another one. We know that the first term, whoops, change the red. The first term is going to be x and x. See that? Because we know there's only one possibility. X and x, x and x, first times the first, and I'm just filling them all in because I'm not sure which one I'm going to use. Then the last term is negative 10. Now, how many ways can I get negative 10? What two numbers can I multiply to get negative 10? Negative 2 and what? Positive 5. Positive 2 and negative 5. Everybody follow that? What's the other two? Negative 1 and positive 10. And what's the other one? Positive 1 and negative 10. Everybody see what I'm doing? I'm taking the negative 10 and I'm saying, how many different ways, how many different numbers can I multiply together to get negative 10? How many different ways can I get negative 10? And then I just make a list of all the possibilities. So I've got the first and the last. Now I'm trying to figure out, where do I get this negative 3x? Well, do the FOIL thing. The OI, outside and inside. The first, the last, and the OI, add them. So I go outside. What's x times negative 10? Negative 10x. Inside, positive 1x. What does that give me? Negative 9x. Is that what I want? Nope, I want negative 3, so that one's no good. So I'm thinking, now watch what I'm thinking here. If I had plus 1 and minus 10, I got negative 9x. If I had minus 1 and plus 10, I would get positive 9x. So that one doesn't work either. See why I'm marking that one out? Now I'm down to using 2 and 5. You go, oh, wait a minute. Look at this. Watch. If I put a 2 here and a 5 here and say there's one way to get 10, but since it's negative, one is negative and one is positive, it's like, oh, wait a minute. Then if I add negative 2 and 5, I get positive 3. But I want negative 3, so that would be 2 and negative 5. See what's going on? So where's 2 and negative 5? Right there. 2 times negative 5 is negative 10. And outside, negative 5x. Inside, positive 2x. And I get negative 3x, and that's what I wanted. You follow me? You see that process? Okay, so what I put in for my answer? X minus 5 and x plus 2. And that's the answer to the problem that says factor. Any questions? Are you having fun yet? No. Let's do another one. Okay. Look what happened here. They've got 3x squared. So that means I could have 3x and x. Oh, that's the only way to get it, couldn't it? So then I just put, okay, so if there's only one way to get that, I put that in every one of them. 3x and x. 3x and x. 3x and x. The first times the first gives me the first term. How do I get 3? How many ways can I get 3 multiplying? 1 and 3, or what else? Negative 1 and negative 3. Remember to think of all the possibilities. That's pretty much it, isn't it? Everybody see that? So, I can either put 1 here, plus 1, and plus 3, or I can put plus 3 and plus 1. Or I can put minus 1 and minus 3, or I can put minus 3 and plus 1. And then I do, so I've got the first and the last, now I do that OI thing. And so let's take the bottom one here. Outside, what's 3x times 1? 3x. Inside, minus 3x. That would be 0. No, I don't have 0 in the middle. I have positive 10. So do you follow me? That one doesn't work. So I mark that one out and try another one. Now there's 3 more to try. Let's call them A, B, and C. Do any of you want to pick one that looks like it might work?
B.
C?
B.
B? Let's try B, somebody says. So I do outside, and what do I get? 3x. Inside, and what do I get? 3x. And that adds up to what? 6x. Nope, that didn't work either. So mark it out. But it looked good. You understand? See, and this is why some people don't like factoring. I looked at it, I picked one, it didn't work. I don't like this process. Well, now we're down to 2. Somebody want to pick between A and C? A, somebody said. Let's try A. I do outside, and what do I get? 3x times 3 is 9x. I do inside, I get 1x, and that adds up to what? 10x, that's the one right there. Everybody follow what's going on? And if you would have picked C and it didn't work, then what would you do? Say, well, I only have one more to try. You go, you mean to say to find the one correct answer, I might work all 4 of them? Yeah, but don't you like just crunching numbers and running things through your head? And can you see the more you practice this stuff, the better you get at it anyway? So the answer is 3x plus 1 times x plus 3. And who would have thought? There you go. Number 16. Solving quadratic equations. Before we were factoring. Now we're going to solve them. The thing is, for number 16, they've already factored it. What would this be if you did FOIL? First times the first would be x squared. Okay? Outside, inside would be what? 3x and 2x plus 5x. Last times the last would be plus 6. You understand that this is the equation that they started with? They just already factored it for you on the page. And the only reason I'm going back like that is to give you some practice with this process to see how it works. So now watch what I have here. Now I have x plus 2 times x plus 3 equals 0. How do you get 0 for an answer when you multiply two things? What does one of them have to be? So either this is 0 or this is 0. If this is 0, then x equals negative 2. You go, how do you get that? Okay, what would I have to put in place of x to zero that out? Negative 2. So negative 2 is one possibility. What if it was x plus 3 is 0? What would zero this out? What would turn that into 0 if x was negative 3? And if you don't see that, jumping way over there like that, then just go ahead and put x plus 3 is 0, minus 3, x equals negative 3. I mean, you can just work it out that way too. Either way, whatever works best for you in terms of your mental framework, whatever makes it work, that's what you do. So, the answer, when it says solve, the answer is a solution set out here, and there it is right there. The set whose elements are negative 3 and 2. There are two solutions. There are two numbers. There are two numbers that I can put in place of x to make a true sentence here. And what are those two numbers? Oh, not 2. Is it negative 2? Yeah, negative 2. Made a mistake there. Okay, negative 2 and negative 3. So let's come over here. Let's put negative 2 in place of x. That would be 4 minus 10 plus 6. Sure enough, that comes out to be 0. Let's put negative 3 in there. Is that the other one? Let's see if it works. Negative 3 squared is 9 plus minus 15 plus 6. Sure enough, that zeroes out too. You follow what I'm doing? I'm putting my solutions back in the original equation to see if they work. Any questions? Number 18. Now here again, they've given us the fact, they've already factored. But what would that look like if it hadn't been factored? That would have been x squared. Then what? Minus x minus 30 equals 0. Can you do that in your head? You say, I can do the first and the last. I'm not sure about the middle. Well, then just go outside. Negative 6x and positive 5x would be negative 1x. See what's going on? So, if this times this equals 0, then either what? Either this is 0 or this is 0. And if that's the case, then the solution set is negative 5 and 6. You follow what's going on? That means I could put a negative 5 in up here, and I would get a true statement, or I could put 6 in up here and I would get a true statement. All right. Questions? Number 20. Now they did 3 of them. So that means I have 3 choices. Either x plus 1 is 0, or what? X plus 2 is 0, or what? X minus 3 is 0. And what would it take to zero this out? What would x have to be to turn that into a 0? So there's the first one. What would x have to be to turn that one into a 0? There's the second one. What would x have to be to turn that into a 0? There's the third one. So now I have 3 solutions that would work. And are you wondering why I don't multiply this out? Because it gets real messy, that's why. I mean, I could, but it just takes time. I wanted to show you where they're coming from, but if If you had this one, you'd have x squared, what, plus 3x plus 2 times x minus 3. So you'd end up with x to the third and a whole bunch of other stuff in between. It would just get a little messy. Number 22. All right, now it's not so obvious, is it? What would turn that into 0? Now watch this. 3 times something plus 5 equals 0. Or we could go 3x. Yeah, let's just do it that way. Let's just go 3x plus 5 equals 0. Then that means 3x minus 5 equals negative 5. Divide by 3, divide by 3. So x equals negative 5/3. So see, that's my first one. But watch this. I'm going to put it over here. 3x plus 5. How would I turn that into 0? What would I put in place of x to turn that into 0? This is so cool when you learn this little trick. See this 5? I put a negative 5 over up here, and I put the 3 underneath. And now 3 times 3 cancels, or 3 times negative 5 is negative 15, divided by 3 is negative 5, plus 5 is 0. So do you see how you can look at what's there and say, okay, so my solution is going to be the opposite of this number, negative 5, divided by this number. If you don't see that, don't worry about it. Just work it out like this, and you'll still find it. X is negative 5/3. Then the same thing here. X is negative 7/4. And that's what you put in place of x to 0 this one out. And the only reason I'm doing some of this fancy stuff is for those of you who had a background with this, it won't take you as long to do the homework. If you haven't had any background with it, then you'll be doing this process right here all day long. And it'll take you longer to get the assignment done. But if you work all of these problems and you run your little mind, if you run all this process through your mind, you'll be amazed at how much of it will stay with you. Number 24. Now they didn't factor it, so I have to factor it. But you know what? I noticed a 3 here and a 27. So I'm thinking I can simplify this thing by just putting 3 out here and having x squared minus 9. Now what happens when I divide by 3 on both sides? I end up with x squared minus 9 equals 0. Probably the most direct way is to go, well, then that means x squared would equal 9. That means what squared would equal 9? And that would be 3 or negative 3. But the book shows another way to work it. Let's just do it that way. Let's turn over here and go x squared minus 9. And I'm going to factor it. Equals 2 things multiplied. Well, this is the first term, so I get x and x. This is the last term, so I can either have negative 3 and positive 3, or negative 1 and positive 9, or positive 3 and negative 3, or positive 1 and negative 9. You follow where I'm putting all my possibilities in there? Now, let's add these two together, and what do you get? 0. That's why there's no middle term. Let's add these together, and what do you get? 8. That one's no good because that's a middle term. Add these together, and what do you get? 0. So that one would work too. Add these together, and what do you get? You get negative 9, and that's no good because we don't have a middle term. So because there's no middle term, you just go x and x, and then negative 3 and positive 3. And those are the two factors. Now watch what that means. So let's come up here and change colors. X whoops, I thought I was doing it. X minus 3 times x plus 3 equals 0. So what would zero this out? 3. What would zero this out? Negative 3. So there's your solution. Negative 3 and 3. You follow what's going on? There's a couple of ways to get there. Depending on what kind of math experience you've had in the past, you pick the method that makes sense to you. 4x squared plus 1 equals 65. Well, if I subtract 1 from both sides, I get 4x squared equals 64. And if I divide both sides by 4, I get x squared equals 16. So what two numbers multiplied would give me 16? Negative 4 and 4. Everybody follow that? Negative 4 times negative 4 is 16. Positive 4 times positive 4 is 16. So I have two solutions. Now, the textbook, again, it says, oh, x squared, it'll have this as x squared minus 16 equals 0. Then you make your two parentheses. And first term, x and x. And since there's no middle term, you have to use 4 and 4. So they cancel each other out, and one is plus and one is minus. You see what they're doing? And so then they're saying, okay, so to zero that out would be negative 4. To zero that out would be 4. So 4 and negative 4 are your two solutions. You just decide which way makes the most sense to you, and that's the way you work it. What do we got here? Number 28. Now they have 3 of them. But it doesn't matter how many they give you. What happens is we go, okay, 2x equals 0, x plus 7 equals 0, or 2x minus 3 equals 0. Because one of those has to be true to get an answer of 0. So what are the roots? Well, if 2x is 0, then that means x is 0, so that's one of them. What's the next one? What zeros this out? Negative 7. What zeros this out? You go, oh, I don't see that one. Okay, then just work it out. 2x minus 3 is 0. 2x equals 3. X equals 3 halves. So it's 3 halves. There are your 3 solutions. There's the answer to number 28. Is it making sense? 32. Finally, they gave us one where they didn't factor it, so we have to. How do you get the first term? X and x. How do you get the last term? Well, it could be 2 and 4, negative 2 and negative 4, or 1 and 8, or negative 1 and negative 8. You follow how I'm putting all the possibilities down there? Now, here's A, B, C, and D. Pick one. Which one do you want to try first?
B.
B? Did you say B? Let's try B. X minus 2 and x minus 4. I do the outside, and I get negative 4x. I do the inside, and I get negative 2x. And that adds up to negative 6x. Sure enough, you found it. Now, what that says is, this times this equals 0. So, I'm not done yet. So, what's the solution set? What zeros this out? 2. What zeros the second one out? 4. Everybody follow that? So, there's the answer. Questions? Let's do number 36. 6x squared plus 17x plus 5. Well, okay, we could have, for 6x squared, we could have 6x and 1x, and 5 and 1, or 6x and 1x, and 1 and 5. Or we could have 2x and 3x, and 1 and 5, or 2x and 3x and 5 and 1? Now, couldn't we also have negative 5 and negative 1? Yeah, you could, but that would give you a negative number in the middle, wouldn't it? And since this is a positive 17x, we don't have to mess with negatives. You see how I can kind of eliminate some of the possibilities? Otherwise, I would have 1, 2, 3, 4, 5, 6. I would have 8 different choices to choose from. And you say, yeah, but if I'm going to get a bunch of negatives and I know the answer in the middle is positive, then that means I'm only going to use these ones that are positive numbers. So let's call them A, B, C, and D again. Which one do you want to try first? A, B, C, or D?
C.
Nobody wants to try anything first. Just say a letter. A, B, C, or D?
C.
C. You like C? Okay, let's do it. 2x. So I do outside and I get 10x. I do inside and I get 3x. That adds up to 13x. That one is no good. Pick another one.
B.
What?
B.
B?
Yep.
B. I do outside, I get 30x. I do inside, I get 1x. That adds up to 31x. That's no good. Pick another one.
D.
D. 2 times 1 is 2. So that gives me 2x. 15x. Oh man, there it is, 17x. There's the keeper right there. Who would have thought? So what zeroes out? So now we have 2x plus 5 times 3x plus 1 equals 0. So what zeroes this out? Negative 5 halves. What zeroes this out? 1/3. Negative 1/3. Everybody follow what's going on? You go, yeah, but the problem is that there were 4 choices and I picked 2 wrong ones first. That's not a problem. You're getting lots of practice doing this stuff, and you're developing skill in one of the most useful problem-solving strategies in the world, called guess and check. Guess and check. Trial and error. It's a marvelous problem-solving strategy. Try one thing. If it doesn't work, you try something else. Ah, 39 to 54. Solve with the quadratic formula. Do you know the quadratic formula? There it is, right there. Write it down. And here it is underneath. I'll copy this problem over again. 6 6x squared plus 17x plus 5. Is that one of them? How come I don't have that numbered? Oh, I know what I'm doing. I just decided this problem that we just worked, yeah, 6x squared plus 17x plus 5. I said, let's do that one with the quadratic formula just for fun. So we work it both ways just to see what it's like. Okay, now did you catch you got the quadratic formula written down? Okay, you need one more piece of information. This is A, this is B, and this is C. Every time you label those parts. So what goes in this first space here? B, 17. What goes in this space here? Right here. What goes in that space? 17. Everybody see where that's coming from? What goes in this space? A. What's A?
6.
And what goes in this space? C. 5. And what goes down here? A. What was A? 6. Everybody follow where I'm getting the numbers? So, the answer to this problem, does anyone know what 17 times 17 is? Take your calculator and do 17 times 17, and what do you get?
289.
289. Minus, what's 5 times 6? 30. Times 4, 120. What's 289 minus 120? 169. Does anyone have a calculator with a square root button on it?
13.
The square root of 169 is 13. Isn't that cool? So now, watch what happens. I have x equals negative 17 plus or minus 13 divided by, what's 2 times 6? 12. What's negative 17 plus 13? So that's negative 4 over 12. What's negative 17 minus 13? Is that negative 30 over 12? You go, that's not the same answers we got up here. Well, wait a minute. Can we reduce that down? That would be negative 1/3. And this would be divide by 6, negative 5/2. Does that look like what we got before? Well, look at that. Negative 1/3 and negative 5/2. Now, the reason I worked this problem, the one we just worked, by factoring, is I worked it with the quadratic formula. Now that you've done it both ways, which would you rather, what's your preferred way of working a problem? Using the quadratic formula or factoring? Let's do another one. Number 40. This is one of the problems in the book there. And what's the first thing I do? Okay, you have to have that formula written down someplace, because I have it in my head, but you probably don't. So you want to write it down. And what is this? A. What is this? B. What is this? C. Every time you circle the parts so you don't forget the negative signs. You circle it and you label them. Now what goes in here? What letter is in here on the formula? So what number is B? Negative 7. What goes in here? What letter is in here? B, so that's negative 7 again. What goes here? In the formula. Do you have it written down somewhere?
3 and 2.
A, so that's 3. And what goes here? The letter C. And that would be 2. And then what goes down here? A, that would be 3. Everybody follow? You do the same process every time. But you have to have the formula on your paper somewhere. So let me come back down here. If you didn't write it down before, copy that formula down in your notes. You're going to need it when it comes time to take the test. So just put it in your notes and carry it with you. And what happens? Screen pops up and jumps at me. That's what happens. So now what do I do here? What's the negative of negative 7? That would be 7. And this is x equals 7 plus or minus what? What's negative 7 squared? 49. What's 49? What's 2 times 3? 6. Times 4, 24. What's 49 minus 24? 25. What's the square root of 25? 7 plus or minus 5 divided by 6. 7 plus 5 would be 12 divided by 6. 7 minus 5 would be 2 divided by 6. So what's my solution set? 2 or 1/3. You like that quadratic formula? Doing this by factoring could get a little messy. Number 48. Same thing again. Oh no, it's not. They had it equals -5. It has to equal 0. So now this is A. This is B. This is C. Then put down here. What goes here? B. So that's -12. What goes here? B. So that's -12. What goes here? A. So that's 7. What goes here? C. So that's 5. What goes down here? A. So that's 7. Everybody see where I'm getting the numbers? So now, what's negative and -12? X equals 12 plus or minus. What's 12 squared? 144. Minus, what's 4 times 5? 20 times 7 minus 140. That would be the square root of 4. What's the square root of 4? 2 divided by 14. So 12 plus 2 would be 14 over 14. 12 minus 2 would be 10 over 14. So the solution set would be 1 or what? 5 over 7. Do you like the quadratic formula? I mean, it gets you there straight away without any guessing and checking stuff. You just have to have it written down to keep using it. Okay, problem number, skip 55. Don't work 55. For 56 through 60, it says use the Pythagorean theorem. Do all of you know the Pythagorean theorem? A squared plus B squared equals C squared. And this is A, and this is B, and this is C. Have any of you seen this picture before I have up here? Okay, A is 3. What's 3 squared times 3 squared? 9. B is 4. What's 4 squared times 4 squared? 16. C is 5. What's 5 squared times 5 squared? 25. What's 9 plus 16? 25. You know why it's called the Pythagorean theorem? Because a guy named Pythagoras discovered it. Just think, if you discovered something like this, your name would be in all the math books in the world. Why didn't one of my ancestors discover it? Then it would be called the Bonine theorem. Well, too bad. They didn't do it. Use the Pythagorean theorem. So now we've got the theorem here, and this is where it comes from. I've got, question 56 says what? I have, what's it say for 56? The sides of a right triangle are consecutive even integers. So I just said consecutive even integers. I just picked them, 2, 4, 6. Would that work? Well, if it was 2 and 4 and 6, because this is always the longest side, what would the Pythagorean theorem say? 2 squared plus 4 squared equals 6 squared. Is that true? 4 plus 16, does that equal 36? Yes or no? So that's no good. So let's try another one. How about 4, 6, and 8? Then that would be 4 squared plus 6 squared Since we've been using trial and error, let's just mess around a bit. Plus 8 squared. What's 4 squared? 16. What's 6 squared? 32. What's 8 squared? Equals, not plus, equals. A squared plus b squared equals c squared. 64. Does 16 plus 32 equal 64? Nope. Let's try another one. 6, 8, and 10. Because it says they're consecutive even. So what's 6 squared? Plus 8 squared equals 10 squared. 36 plus 64. Does that equal 100? Voila, I just found it. 6, 8, and 10. You didn't like trial and error? Okay, let's try something else. Let's put another triangle up here. And let's call this one x. Then the next one would be x plus 2, because it would be 2 more than x, right? And then this one would be x plus 4. See that? Like 2 plus 2 and then 2 plus 4, 4 plus 2 and 4 plus 4, 6 plus 2 and 6 plus 4. So now I can use the Pythagorean theorem, come over here, and take this one and watch what you can do. If you don't like, guess and check. X squared plus x plus 2 squared equals x plus 4 squared. And then that would be x squared plus x squared plus 4x plus 4 equals x squared plus 8x plus 16. So I end up subtracting x squared from both sides. I'll change colors here. And I end up with x squared minus 4x minus 12 equals 0. See what's going on? And you can either solve that by factoring or by using the quadratic formula. And it looks like it would be x and x, and 6 and 2. Minus 6 plus 2. So what would zero this out? Negative 2. What would zero this out? 4. Now, since we're talking about the sides of a triangle, could you have a negative 2 for the side of a triangle? Nope, so it has to be 4. If that's 4, this is 6, and this is 8. Wasn't that fun? Not your definition of fun, huh? Number 58 says the hypotenuse of a right triangle is 16 inches longer than the shortest leg. So I just wrote up here x plus 16 and called the shortest leg x. Then what does it say next on problem 58? That the hypotenuse is 2 inches longer than this side. So this side would be x plus 16 minus 2. Because this is 2 inches longer, that makes this one 2 inches shorter. So this one would be x plus 14. You follow that? So now I've got these three numbers. I can use the Pythagorean theorem to go x squared plus x plus 14 squared equals x plus 16 squared. And work it out just like we did the last one. If you don't like that approach, you can do this. You can call the hypotenuse x, and then since it's 16 inches longer, this would be x minus 16. And since this one is 2 inches shorter, it would be x minus 2. You follow? You have a couple of ways to set it up, but either way you do it, the Pythagorean theorem says x minus 16 squared plus x minus 2 squared is going to equal x squared. Working it this way. And you just decide which way you want to set them up. Then once you draw your picture, use your Pythagorean theorem to work the problem. For problem 61 to 64, use this formula right here. So problem 62, if you look at problem 62, it says an object is thrown downward from a height of 28. So the height is 28 with a velocity of 4. The velocity is 4. How long will it take to reach the ground? That's the question. What would that be? How long? That would be t, the time. How long? The time it takes to reach the ground. So I just take this formula and I plug in. What is that all about? Where did I get 25? 62 is 28. 28 equals 5t plus 4 plus 4. 5t squared plus 4t. So I subtract 28 from both sides, and I end up with 0 equals 5t squared plus 4t minus 28. Now, I could either factor it or use the quadratic formula. The quadratic formula would say this is A, this is B, and this is C. So what goes here? B, that would be 4. 4. A, 5. C, negative 28. And 2A, 5 down here. And then you just do the work. 4 squared is 16. Negative 28 times 5 is, what is that? 140 times 4. You guys have a calculator, go ahead and do it. 560, is that right? Am I right so far? And then that's a positive, so add that to 16 and you get 576. Is that a perfect square? I don't think it is it? When you hit your square root button, does an even number come out with 576? What is it?
24.
24. So now the time would be negative 4 plus or minus 24 divided by 10. Now, negative 4 minus 24, that would be a negative number. Time is going to be positive, so it would be negative 4 plus 24. That would be 20 over 10. So that would be 2 seconds would be the time. You follow the thinking? The one that doesn't make sense is called an extraneous variable. I mean, it'll solve the equation, but it wouldn't work in real life. 64, the same kind of thing again. Oh no, it isn't, because in 64, how long will it take a package to fall? Now they want to know the height. And they give you the velocity. No, they don't. No, how long? No, how long would be time? That's the time again. They give you the velocity and the height. It's the same kind of problem again. Number 66. They gave you a different formula for 66. C equals all of this. And 1300, if that's the cost, equals all of this. So you get an equation that says this, and you can factor it, or use the quadratic formula. Wait a minute. What two numbers, watch this, what two numbers multiplied would equal negative 1200 and added would equal 10? How about 30 and 40? And make 30 negative and 40 positive. You like that? And since we're talking about time, then it would be x minus 30 times x plus 40 equals 0. So x would either be 30 or negative 40, and we'll go 30. So it's going to take 30 seconds. No, 30. What are we getting here for number 66? I got the answer. I just know, 30 customers. Okay, so I need 30 customers. Number 69. We're out of time. I was going to work that for you. So it's one of your problems. So if you want to stay here and have me work it for you, I will. But we're out of time, so you can take off. But before you do, I have a couple of announcements. Stop at 69. On Monday, Wednesday, and Friday of next week, class meets in the Sabre. Is it S-A-R-B-E?
No, it's C, but it says
S-A-B-R-E? There you go. I'm just copying down the emails they send me. In room 101 and 102. And class will begin at 9:45 because it'll take me that long to get there from my other class and get things set up. So class will start at 9:45. I might get there earlier, but like I did today, but it won't always happen. And help with math homework in the Clark Academic Center. Did I get that right? CAC? Is that what it's called? There's not an L in it. See, it ought to say C-A-L-C. The Clark Academic Learning Center. No, the reason, what's C-A-L-C is calc. Oh, like calculus. That's what it should be called over there. Okay, after 8:30 p.m., Monday, Tuesday, and Friday, or after 5 p.m. on Thursday, and anytime on Saturday. If you would like to help an online student, just write down donna.m.davis@calvary.edu. She is crying, help! Can someone help me with my math homework? If you would be inclined to help her, send her an email. She would love to have you come over there. As much as I would like to help her, I have grandsons playing basketball and wrestling. And I have made a decision that my grandchildren take priority over my work. Now, if you were to ask me, would I rather be doing math than watching wrestling or grandchildren? That is not a question that this grandfather entertains. Grandchildren are so important to him that he goes to their activities no matter what. Even if they put him to sleep from time to time. So if you can help Donna, she would love to have the help. If you want to stick around and have me work one of your problems for you, number 69, I'll do it. Otherwise, you can just take off. I'm going to do this for the people online, but I know you've got things to do, so I'll go ahead and do it for the people online. 69 says, to attract more students, the campus theater decides, and you won't offend me if you leave. I mean, you understand, I don't get offended. I have so much fun with math, you couldn't offend me if you wanted to. It's just such a high note in my life. So do whatever you have to do. But I'm doing this for the online people. So if you want to stick around and watch what he does for online people, if the room is empty, you can watch me operate that way. If you want to work it and have a question, go ahead and raise your hand. To attract more students, the campus theater decides to reduce ticket prices by X dollars. So that means they took the $5.50 and subtracted X. You follow me? So that's the ticket price. So A, what's the expression representing the new price for tickets? There it is right there. $5.50 minus X. if the number of tickets sold, the tickets sold is right here. You go, what is that? That's what they said was the tickets sold. Don't argue with them. Just take the information. If the tickets sold were 100 plus 100x, and I have no idea what they mean by that, but I don't care. I'm just taking the information and using it. And the revenue is the number of tickets sold, that's this number, times the price of each ticket, that's this number, then that's the revenue. So now, B, what's the expression for the revenue? There it is, the TS times the new price. C, if the owner wants to receive $17,980, whoops, wrong one. If the theater wants to have $750 in revenue, so I put in place of revenue 750, now I have 750 equals 100 plus 100x times this number here. And I use that distributive property to multiply, and I get 750 equals 550 plus 500x plus 550x, and then this minus x minus 100x minus 100x squared. So I subtract 550 from both sides, and I get 0 equals 200 plus 450x minus 100x squared. And I'm going, hey, I can make this easier by dividing everything by negative 50, because I don't like that negative. And I end up with 4 plus 9x plus 2x squared. Or rearrange it so it looks better. 2x squared plus 9x plus 4. This is A. This is B. And this is C. So I come to my formula, and I go 9 here, 9 here, 2 here, and 4 here. And then 2 here. Everybody see what I'm doing? So now I have negative 9 plus or minus 81 minus 36. What does that give me? Oh, not 36. It's, what is it? 32. What's that give me?
49.
49. What's the square root of 49? Negative 9 plus or minus 7 divided by 4. I'm either going to have negative 16 divided by 4, or I'm going to have negative what did I get? 2 divided by 4. So x is either negative 4 or x is 1/2. Did I make a mistake in here somewhere? Huh. What do they show for an answer in the back of the book? I might have made a mistake on this one.
C is 50 cents or $4.
What's it show for the answer for 69?
For C, it's 50 cents or $4.
50 cents? So would half, would negative 1/2, would that be a $0.50? So I guess I did get it right. It was 50 cents. All right. Okay, let's shut things down here, and then I'll help you with your homework.